Hi, in this video, I have the distinct pleasure of having as a guest the distinguished and really wonderful naval analyst Emma Salisbury, and hopefully I've actually pronounced the name correctly. As she said, it's Salisbury like the steak, but which is only of some value because in the States we probably pronounce that wrong. Anyways, so the subject for today and the subject of this video and what I've asked Emma to come on and speak to me about is trends in modern naval warfare and sort of looking into the future. What's going on now? What can we expect to go on now? And, what should we think about all this? So, Emma, just to start off, I think it would be best perhaps just to introduce you but let you introduce yourself. Like, who are you? What do you do? And how on earth did you find yourself being a naval specialist?
Well, firstly, Michael, thank you so much for having me on. It's a real pleasure to come on and talk to you. So I am, as you said, a naval analyst, but I have a very strange route to get there. So I'm currently the Sea Power Research Fellow at the Council on Geostrategy, which is a think tank based in London. And I'm also a fellow at the Royal Navy Strategic Studies Centre. But I actually started out in politics. So my undergraduate degree was in philosophy, politics, and economics, which is kind of a feeder school almost for the civil service in the UK. So most people in politics and the civil service always joke that we've all done a PP degree at Oxford. So that's what I did. And I went into work for members of parliament. So I started out as an intern in the House of Commons, and I am actually still there part time. So it's been 16 years that I've worked in British politics, which is a extraordinarily long time now that I say it out loud and a little bit scary. So yeah, so that's where I started out, and I had about 10 years between my undergraduate and my master's degree. And my master's degree was in Middle Eastern politics. But as part of that, I did quite a bit on kind of the war studies area. And one of those was a module specifically on war studies, so kind of the classic, Clausewitz, that kind of thing. And I just absolutely loved it. And the professor who taught me, Antoine Bousquet, it's really all his fault that I did a PhD because he was so inspiring and helpful and encouraging. So he let me do a PhD, which I did on the military industrial complex. So that was focused on the United States, and kind of mapping out the history of the military industrial complex, how it works, and how it affects national security outcomes. So that was my PhD, which I finished earlier this year. And
Congratulations.
thank you, thank you. It was a long road. I did it part time while still working, so that was it took a long time, but
Mm.
it was wonderful to do. And as part of that, I did some case studies. So I wanted to be joint in my case studies. So I did a Navy one, an Air Force one, Army one, and then a couple of others. And my Navy one was the littoral combat ship. And I thought to myself, well, this is a really interesting case. I'll see if I can get something published somewhere on it. And I got it published in War on the Rocks. And everyone just assumed that I was a navalist because I published on the LCS.
Uh-huh.
And they kept asking me to write about Navy things. And I thought, brilliant. So I just kept going. And now I am a professional naval analyst. So it was slightly accidental as to which branch I went into, but I absolutely love naval stuff. So it's worked out spectacularly.
Did everybody ask you to do Navy stuff because there's a need for it? I mean, does that? Uh, I mean, obviously, one reason why they want you to do it is because you're very good, but also, does it reflect any like is there like a gap for like are there just too few navalists to go around, and then when suddenly one pops up, they're like, oh my God, there's a navalist, a live navalist. Let's get them to do more.
I don't know if it's that or whether it's just that in the countries I was looking at, the Navy is a big deal. So
Hmm.
my focus was on the United States initially. And obviously, given that the US's geographical position, the Navy is always going to be hugely important because it's on its own continent with a friendly neighbor to the north and a friendly neighbor to the south. So anything that the US does that doesn't involve an attack on the homeland is going to involve the US Navy
It's
in
true.
some shape or form. So there's a lot of scope there for thought and for academic thought, but also for kind of operational stuff. So I think that has something to do with it. And then also it's the same in the UK. I mean, the Royal Navy is Britain's senior service, and we do maritime stuff. That's our focus and has been historically for hundreds of years. So kind of fit very well with my British side as well, because we are a very naval country, we're an island, and most of our kind of contributions to NATO are naval based.
Hmm.
Our nuclear deterrent is naval. So I think it's partially, there's a lot more naval stuff to be thought about in my specific context than there is kind of land based or air power based. That's not to say I wouldn't have been welcomed in either of those domains, but the naval stuff I think had a lot of space for me to go into.
So why don't we get into it then? Like, so the question is, all right, let's start this way. Off the top of your head, like if I were to say, all right, let's talk about trends in modern in naval warfare. What's the first thing that comes to your mind?
It's definitely uncrewed systems. It's just such a massive shift in, well, operational shift, I guess, because you're not thinking about how a fleet of traditional ships changes. You're thinking about adding in a completely different style of fleet into your traditional platform fleet. I don't think that, we'll see completely automated fleets at all. I think, there will always be a place for traditional crewed platforms, but that transition into operating with traditional fleets plus uncrewed systems, I think, is the big transition that all modern navies are making at the moment. And I think it's that shift in how those two styles of things work together, not only overall, but also in specific capabilities.
Hmm.
I think that's something that's going to have to be very carefully figured out, because I don't think we have been able to predict how these technologies will develop enough to be able to kind of write the doctrine early on. We're kind of doing it as we go, as we experiment. So that's kind of the big transition, I think, well, it's already happening, but over the next 20, 30 years as well.
So explain then what this actually looks like. So is this a question of the ship every once in a while puts up a drone, or are we talking almost like a an escort fleet of like robot vessels, drones or what have you, that are basically kind of slaved to a crewed ship? So it's like a ship plus a few things that are circling around it or doing things for it. Like what do you mean? Like what are you talking about?
All of it.
Okay.
This is the thing that fascinates me about uncrewed systems is the sheer like range of use cases that are possible for drones. So if you look at a fleet of crewed ships, normal crewed ships, you would see probably some kind of uncrewed escort fleet with them, which is directed by those crewed ships. So it's kind of like a loyal wingman kind of
Hmm.
thing. Then you may also have fleets of uncrewed vessels themselves, which are slave to a mothership of some kind that is also a drone. So you could see a mothership going out to a place where intelligence is needed and then dropping a kind of sub-fleet of uncrewed surface vessels, which can then zoom around, do all the intel, come back to the mothership. The mothership can then go back to its home port or its home ship. So there could be fleet structures that are just uncrewed, but different kind of types of uncrewed systems working together. You also have the subsea domain. So you could have uncrewed vessels for intelligence operating below the surface or weaponized, again, in concert with a crewed submarine, perhaps, or in concert with a surface fleet, but then again, maybe not. And then there's also the air component. So you could have like an aircraft carrier that is just for drones, or you could have a traditional aircraft carrier that launches fighter jets and drones, or you could have some kind of mix, depending on what is operationally needed. And then you have the possibility of air drones being launched from a submarine or a much smaller ship as well. So there's just all of these possibilities that I think are wildly fascinating in terms of operational doctrine and in terms of what changes they will bring to how we use navies and how we attack those missions that we expect navies to do, and what kind of combinations of those technologies will be the most useful in performing a particular mission or kind of fleshing out the capabilities of a navy.
So lay out what are the advantages of this? I mean, I suppose it's not, it seems a little bit self-evident to some level, but I still think it's worth kind of like laying out. Like, why would navies be into this? Like, why, what's the motive here?
So there's several kind of buckets for this. So the first one is frankly cost. Uncrewed vessels are cheaper
Hmm.
than crewed ships, and you can have mass from uncrewed vessels much easier than you can have mass from crewed vessels. And then you also have the possibility of those uncrewed vessels being attritable. So you could think about using them in a kind of swarm formation to attack an adversary, but then you don't have to worry so much about losing 10 or 20 or 100 because you can just make more. Nobody's died. You're not losing any more than the price of that vessel itself.
Hmm.
So it kind of changes how you think about mass in naval warfare, and the same in the air domain and the land domain as well. So that's one thing. It also means that navies that are operating in a constrained budget, which I think a lot of our navies are at the moment, can look at capability options with uncrewed systems for cheaper than they would be able to using traditional platforms. So if you look at something like mine countermeasures, it is cheaper to do that capability uncrewed than it is to do it in traditional crewed ways, potentially. So it could mean that when naval planners are looking at kind of fleet structure options, overall those options might be cheaper with
Hmm.
uncrewed systems involved. But uncrewed doesn't mean that you need fewer people. It just means that you're not putting people at risk. So you won't have as many risks, you won't have as much risk to the lives of your personnel, which is obviously a good thing.
Hmm.
You will still need personnel to operate them, to make decisions and so on, but those people will not be in the line of fire. And that is also very important. It's those kind of dangerous and dirty jobs that if you can get a drone to do it, then that means a person doesn't have to do it. And that's a great thing.
So you seem to phrase very carefully the idea that it doesn't mean fewer people,
Mhm.
right? And I feel like just the way you phrase that made me think like you're trying to make a point there.
Yes, yes.
Okay.
I don't think this is something that naval people think or military people think. I think it's something that civilians tend to think, and political people tend to think that uncrewed or unmanned means no crew rather than meaning no crew on that vessel. So I think they tend to assume that systems that are not crewed at their time of use means that there are no people involved in using them.
Hmm.
So, and given that a lot of the cost of militaries at the moment is personnel cost, so recruitment, retention, training, and then, veterans benefits, pensions, and so on. Anything that kind of has a hint of being able to hire fewer people is very tempting. And I think it's important for politicians and civilians not to cling to uncrewed systems as kind of magic fix-all for this kind of personnel problem. The thing is, and also those personnel that you are using with uncrewed systems will need different skills. So you want people who are trained in tech, in engineering, in
Hmm.
computer sciences, in all of those things that come with uncrewed systems, which is a very different skill set from the traditional things that navies have recruited for. So there has to be that shift in we are not only recruiting engineers who can fix an engine on an aircraft carrier, we are also recruiting engineers who can fix drones and who can fix the systems that go with them. Those people will be spread differently and have different skills, but I don't think there will actually be numerically fewer people needed in a navy in the future.
If you're going to add a drone capability to a ship, let's say some sort of surface drone that's slave to the ship, then presumably then this means that you're going to have additional crew members on that ship whose job it is to run and maintain the slave drone. It just so happens that
Mhm.
they're on the ship, they're not on the drone itself. But it
Right.
means actually more people in the crew of the ship. You need more people in the ship than you would have without the drone.
Yes, you'd probably need at least a couple more people to do the kind of physical maintenance of that drone
Hmm.
whilst on deployment. The drone wouldn't necessarily have to be driven from the ship. It could be done from a base on land, like you see in kind of air drone warfare. And, there's these big Reaper drones being piloted by someone sitting in a cabin in Creech Air Force Base.
Hmm.
It's that kind of
Right.
thing. You can do that with naval drones as well. So the drone doesn't have to be controlled from the ship it's slave to, but if you're going to be able to do any maintenance whilst it's on deployment, you're probably going to need a couple of guys to be able to do that, unless you can train existing crew members to fulfill those roles
Hmm.
for what is necessary for that specific deployment, and then have everything else done from land.
And then certain kinds of drones would require even more work, and then maybe
Mm,
even infrastructure on board the ship to be able to work with it. Like to get a surface drone or an underwater drone out of the water so that you could work on it. Like that's all stuff
right,
and people.
right. And it's systems as well. So, a lot of these systems can be modularized. So you have a ship that can take a container which has the drone system within it, and then that container plugs into the ship systems for things like power, data, and then the drone kind of works within the systems that are contained in its box. So there's kind of a lot of options of being able to swap out which drones you have depending on which mission your kind of home vessel is doing. So if you're doing like a minesweeping mission,
Hmm.
you would plug in your mine countermeasures drones. If you're doing ISR, you'd plug in your intelligence drones and so on. So that's one option to kind of make it easier to switch them out, is to have them be regularized as to how they slot into the mothership. And that would mean that each of your hulls could be used for different missions rather than having to specialize.
I've often heard that. So the term obviously that's used for that approach is modularity, and
Mm.
I've often seen that in reference to naval thinking. Like there's this idea that warships should become more and more modular. It's kind of a side question, so I don't want to go too far down that particular tangent. But have navies actually been able to pull that off? I mean, it's been an ideal now for like at least 20 years, but does it exist?
No, so I am very glad you asked me that, because I wrote a very angry article in USNI Proceedings about how much I hate modularity. And I have a chapter of a book coming out early next year, which is a fleshed out version of how much I hate modularity. Um, and it's one of those concepts that, similar to the kind of what I was saying about the uncrewed thing, it feels like a panacea for
Hmm.
wider problems with your fleet structure. And there are capabilities that it does work for, but it's not something you cannot containerize and modularize every single capability. It just doesn't work. So it doesn't solve your problems with making your fleet structure more flexible in itself. It has to be done in concert with other more traditional things to make sure that you're not relying on modularity to fix your problems. And
Well, what are the problems that we're fixing?
so it's because kind of the promise of modularity is that you build regularized hulls. So you'd have, say, 6 hulls that are exactly the same, and they all have the same kind of open slots in them, which can fit the containers, which are all the same size and all have the same connections. And those are your capabilities in that container. So your hull, you look at your hull and you say, right, we need this hull for mine countermeasures.
Hmm.
Bring me the mine countermeasures module. They bring it on a crane, they slot it in. That is now your mine countermeasures ship. It goes off, does its mission, comes back. You say, right, we're done with that mission. We now need this to be an ISR platform. You take out your module, put it back in its warehouse, then you bring out your ISR module, slot that in. It's an ISR ship. So that's kind of the promise of modularity, is that you can do that. And that kind
So
of
thereby
means
you
that
you escape the dilemma of having to figure out what kind of ship you need. The answer is you can have an
exactly,
everything ship.
exactly. And you can have lots of modules stored in your warehouse for all of these capabilities, but they are all reliant on the same hulls. So you don't have to figure out, we need 3 MCM ships, we need
Hmm.
3 ISR ships. You can have both.
Are drones then maybe an alternative to modularity? So what I'm thinking of
Yeah.
is like, let's say you've got a frigate and your frigate's going to, you decide that your frigate's going to need certain core capabilities. It's got to have an air defense capability to protect itself. It's got to have a certain anti-ship surface capability. And it's got to have a certain amount of anti-submarine warfare capability. But you might decide, but because of the compromises, maybe it's got more of one thing than the other. And maybe there are other things that you just decide not to shoehorn into this frigate. But then what you can do is if you decide you need to plus up the whatever capability or add a capability it doesn't have, then rather than this modularity idea, then you basically offload that capability onto some sort of buddy ship, slave ship. I shouldn't use slave. That sounds awful. Um, it's also, it's important for ships to be able to assert their own subjectivity and
Mm, mm.
their autonomy. Yeah, and also we should stop referring to ships as she because it's really just a question of how they self-identify. So that's very important too. So I'm sorry, but so the idea is like then maybe instead of modularity, then using drones is maybe actually a better option.
Yeah, and I think if doing modularity well, I think often does involve drones, and to have your kind of modular container actually just be a home port for a drone capability is actually something that I can see working really well. It's the other capabilities that actually worry me more. So I think being able to slot in different uncrewed systems into extant hulls, I think is probably one of the better uses of modularity because, there are benefits to it. And it does mean that if your capability is not kind of built into the ship, it means that you can take it out, update it, upgrade it, and
Mm.
put it back without having to refit your entire hull. It means that the hulls can go a lot longer without becoming obsolete in terms of capability, because it's just a lot easier to upgrade systems if you can chunk out the module, put it away, get your better module and put it in. And it also means that you can iterate with your technologies and actually test them in the field. So if you have an uncrewed system, you put it to work, there's something that's not quite right, something could be better, you can upgrade that more effectively than you could with a kind of traditional in-ship capability. So there are lots of benefits, and I'm not against modularity as a concept most of the time. It's just that I worry that navies have kind of glommed onto it as something that will fix all of their capability questions and haven't necessarily thought through those wider fleet structure problems because they say, oh, hey, we'll make it a module. Everything that we all need to do will have some kind of module for it. And that's what concerns me. But the drone side of things, I think actually it would probably be a decent way of doing it. So you could have a surface drone module for ISR, then you could have a subsurface module for mine clearance, and then you could have a air module for reconnaissance and so on. And that kind of thing, I think, would be a reasonably decent use of modularity.
I think related then to return to the question of drones, what
Mhm.
challenges are there though, besides what we talked about in terms of the fact that you need people on a ship, you need certain capabilities on the ship to handle certain kind of drones, and then this brings us to the idea that modularity can help with that. What other challenges are there for fleets or for naval commanders that or fleet designs? I mean, just in terms of now that we've got all these drones, increasing numbers, it sounds pretty awesome, but there's always a challenge. Everything just makes a challenge. So what are they like what that need to be sorted out?
I think one of the big ones is something that has bedeviled militaries for hundreds of years, which is command and control.
Hmm.
And the more complicated you make your fleet, the more complicated your command and control is going to be, particularly if you've got lots of small vessels that all need to be talking to each other and all need to be commanded and controlled. So making the fleet more distributed adds to the challenge of command and control of that fleet. And then that is compounded if you're bringing in any kind of autonomy into those systems, because then is there at what point are you bringing the autonomy in? What is the system allowed to do itself? And what does it need a human in the loop to be able to do?
Hmm.
What does that mean for command and control? What does that mean for responsibility for what happens on a mission? And so, and then you also need to be able to physically keep those networks together, because there's the more networks you have within your fleet, the more potential there is for spoofing and jamming and
Hmm.
for the adversary to, disrupt your signals and mean that you'll get cut off from your beautiful autonomous fleet. what does it do in that situation? So there's all these questions of command and control that I think will be really important to figure out. And those will only get more complicated the more different systems are all working together.
So
Because
then let's talk about autonomy. Now, is it safe to
mm,
assume that autonomy is a fact and that there's going to be more and more of it?
I think so. It is a valuable capability to have. It's just thinking through how to use it properly is a really, really wicked problem. So kind of operationally, because it's not because when you have something unexpected happen in the fog of war and you have a person there, that person can think on their feet, remember kind of the overarching goals that they've been set by their commander, and figure out a way to achieve them. And you can give that person quite a lot of latitude to figure out the best way to achieve something without being able to contact their commander. And armies have relied on that for hundreds and hundreds of years. You know, if your unit gets cut off, and you have a really great unit commander who can like figure out how to achieve the mission and get back home, you know, all of that with a machine has to be programmed. So all of that has to be thought through in advance through the algorithm to say, if this happens, then what? And then if this happens, then what? And all of that has to be specifically thought about before this machine is sent off.
Hmm.
If you're uncomfortable with autonomy, you would want more control over that process. So you could let it make quite kind of constrained decisions, like if X, then Y, decisions that you've already pre-written in. But then there's kind of the level beyond that, which is giving it more of a decision in what it does. And the problem with that is you can't trace that path of how it made that decision because a lot of these machines use something called neural networks, which are extraordinarily complicated. And what you essentially get is a black box of decision making. So the input goes in one end, something happens, and then the output comes out. And you don't actually know how the machine made that decision. So if you're in a situation where something goes wrong, you don't know how to stop that from happening again. And then if that situation where something goes wrong means that somebody ends up dying, who has responsibility for that death if that death is not covered by the laws of war? So if I mean, you know, this is a very kind of philosophical point at the moment, but it's something we really do need to think about. If an autonomous system kills a civilian, who is responsible for that war crime?
Hmm.
And all of these things do need to be thought through before we commit to the step of putting these systems out on the battlefield. And the other problem with that is that we come from countries that are worried about the ethical dimension of war, and there are many countries which are not worried about the ethical
Hmm.
dimension of war. So there's the other problem of these autonomous systems being used on the battlefield by an adversary that doesn't have the same compunctions about killing people with machines that we do. So how do you counter that?
I was thinking about that in terms of speed. I mean,
Mhm.
the way I understand it, naval warfare, first of all, particularly nowadays, right, when we're talking high-speed missiles, is fast, and things move fast, and then decisions have to be made quickly, and decisions about what threats have to be addressed and who's going to address them and how, right? Who takes the shot and in what order, and everything has to be decided really, really quickly. And this could happen in a super complex environment because there could be swarming drones and multiple attacks in multiple domains. All this stuff is going on. It's happening really, really fast. So the faster you can do this, you know, they talk about the OODA loop, but it's like,
Mm, mm.
at a much larger scale because there's just so much stuff happening. The faster you can do this and respond, the better. And so if you're up against an enemy that somehow can do it faster, then the enemy has an advantage. But then also that's where the greater automation comes in. So the more you dial up the automation, theoretically, the faster you are. And if you're willing to just like flip the switch and go fully automatic, then you could have a real speed advantage over somebody who's not willing to flip the switch for whatever reason and has dialed down the automation for whatever reason. And it's because for Western countries, it's not a technological capability, it's a policy capability. Does this get us into trouble? Or is this just something that we have to live with?
I don't think it's something that we're going to be able to solve soon, because ultimately the question is, do we care about ethics or not? And the answer is yes, we do.
Hmm.
So if we care about ethics, then we are going to have to either dial down the autonomy or figure out a way to make it safer. And that figuring out of safety is a long process. And it's a process that our adversaries probably won't have to do because they don't care about ethics. So ultimately, it's a risk we're going to have to deal with, because we should not give up our worry about ethics
Hmm.
purely for a speed advantage, because that's not who we are. So if that's not going to happen, then we have to be able to deal with the risks on the battlefield that will come from fighting an adversary that doesn't care about ethics.
Right.
So it needs to be priced into how we think about warfare, I
I
think.
sometimes wonder if it's maybe something that needs to be context driven. Imagine you could literally, there's literally a dial, right? Like dial up automation, dial down automation. But in certain instances, like if you're in the middle of the Pacific Ocean,
Mm,
and you're away from any shipping lanes, and you can see on the radar you don't have any like civilian airliners up in the air, then you could really dial up the automation.
right,
And
totally.
in
Yeah,
other
yeah. And especially
contexts,
if you're fighting other drones as well.
right,
Like if there are no people involved whatsoever, then you could just be like, knock yourself out.
swat them away, yeah, knock themselves
Yeah.
out. I had a conversation. I had a conversation with the French general that I've often referred to this conversation. I just find it very interesting. It was the French general who was in charge of some of the high tech programs that the French army is working on, and we were talking about automation with things like collaborative warfare and slew to queue capabilities and tanks. And I said to him, the French army, like all Western armies, really insist on man in the loop. It's very important
Mm.
for legal, ethical, all sorts of really very valid, important reasons. And I asked him, like, surely there's not some box in the back of some switch in the back of the box in your Leclerc tank that you can flip, and the whole thing becomes fully automatic. And he did not answer the question, but he then said that he thought it was almost going to be inevitable, fully automatic. And what he said was, he saw it happening in urban warfare, because in his mind, urban warfare is a space in which it's the opposite of the Pacific Ocean, I suppose, but the distances involved and the times involved and the speed of everything, right? Somebody firing at you with an ATGM at short range, you've got like less than a second to respond. Humans can't do that. So that's just going to dial up. And he was spoke about it as if like he imagined the French army finding itself in a situation, or any army, right, finding itself in a situation where it almost has to. In naval context, uh, it's not the distance thing, but it's still, I guess, the speed. The speed is so relevant just because of the speed of a lot of of a lot of these weapons, and perhaps the complexity, but then also again context. So maybe sometimes you could just like knock yourself out, just like dial it all the way up, dial even up to 11, and you'll be good. But other times, no. But I guess everything has to be thought out, right? Then it's just a
Mm,
question of
mm.
thinking through. Um, a kind of related question, and this is something that I thought a lot about when I was at Rand. I did a project on this is why I had this conversation with this French general about the French army approaches to network warfare. And one of the things that I asked them when they're talking about things like collaborative warfare and the network warfare was, is this revolutionary or evolutionary? And they really insisted that this was just evolutionary, that this is not changing anything. It's not a revolutionary change. Although they did say, as a caveat, one of the guys I talked to, one of the people whose jobs it was to think about the impact of network warfare on doctrine, he insisted it was not at all a game changer. He did say that artificial intelligence might be a game changer, which I thought was interesting. So I guess I've got two questions for you then out of all of that. Like one is what is your perspective on evolutionary versus revolutionary? And is this a game changer for the way navies fight? And then if we can remember and not get too distracted by whatever, uh, like what about like artificial intelligence and how does this impact naval warfare? So let's begin with the game changer question.
Sure. I think I'm going to agree with the French general you spoke with. I actually don't think there is such a thing as a revolution in military affairs at
Hmm.
all. I think every technology is evolutionary on what came before it. And I think if we're going to try to pick out technologies that have revolutionized warfare, you either end up with a list so long that it's pointless, or you end up with maybe two or three things, and then you can argue about those as well. So I think evolutionary is the best way to look at any technology, and also to look at uncrewed systems, drones, AI, all of that. I think all of it is evolutionary. The thing that I think is difficult to pass out when it comes to AI is it's a technology that's more like something like electricity than it is specifically a military technology, because it is something that can be used in so many contexts across civilian, commercial, military, everything.
Mhm.
So it's that kind of base technology rather than something like gunpowder or the horse stirrup, or whichever other technology you can think of that has revolutionized warfare. So
I forget
it's
about the
very
horse
much
stirrup.
it's
It
always
was
the horse
huge.
stirrup.
Yeah.
Always the horse stirrup.
Game changer. Yeah, it's huge.
Huge, yeah.
Yeah,
No, I
huge.
mean, if you want to have a conversation about horse archers, I can also do that, but maybe another time. Um, but because AI is such a pervasive technology, it's very much, when you think about its use in warfare, you have to think about the specific way in which it is used, like the specific capability that is enhanced by AI,
Hmm.
not think about AI separately in itself, because then you're thinking about electricity or the telephone or, something like that. So I think it's important that we recognize the different ways in which AI will be used in warfare, how different those are, and what different challenges each of those will pose,
Hmm.
and that we don't lump everything together into AI in warfare as kind of a too much of an umbrella, because I think doing that risks eliding together a lot of the specific challenges that we'll face using AI in those kind of more siloed capabilities. And then in terms of looking at those capabilities, a lot of those will be very important for naval warfare and very important in different ways for land warfare and air warfare and space warfare and cyber warfare and all of the domains that we have now, but also for joint warfare, because, a lot of Western militaries in particular at the moment are on their maybe third or fourth iteration of combined arms,
Hmm.
joint force, integrated force, whatever the buzzword is at the time, because we all realize the importance of not only having an army and an air force and a navy and a marine corps, but having all of them be able to fight together. And I think AI will also be a useful technology for those kind of joint command and control strategic side of things. It will come into everything in some way, but it's important that we think about not only the service specific, domain specific applications, but also those overarching ones.
One thing I wanted to ask you about is this question of visibility and transparency. And I've read quite a bit at this point, like of the sort of the classic naval strategists. We're talking Alfred Thayer Mann, Gillian Corbett, Raoul Castex, and it's all very interesting. But the one thing that makes me think maybe this is all completely out of date is that they were all writing at a time where ships were operating more or less in the dark, where there was almost complete fog of war. They generally could not see where the enemy was, and nobody knew where the enemy was, and they're all just sort of roaming around in the ocean until they bumped into one another. And but now, at least with peer adversaries now have, theoretically at least, almost complete transparency. So you can always see where the enemy is, and the other fleets, the enemy, everything. I guess for hopefully submarines are still invisible, but so does it? So I was thinking about that. So there's some questions there. Like for one thing, how transparent is the battlefield really? And then what are the implications of that? Like, am I right in thinking that maybe this is why we should take our man and our Corbett and our Castex and like toss it all out because it's all now irrelevant? Like, is that the game changer, perhaps?
I think if I ever suggested that we should toss Mann and Corbett and Castex out of the window, I would be immediately attacked by a whole bevy of naval historians. So I would never agree to that. I think the important word you used there was theoretically. The ocean is
Hmm.
theoretically transparent. And I think that is either true or becoming true. But the question is it actually transparent? And part of the problem is, frankly, that the ocean is massive. So unless you have an infinite amount of funding, you are not going to be able to extend your beautiful web of sensors across the entire ocean. It's just not feasible.
Hmm.
So you're going to focus your ISR networks on important places. So in a British context, for example, we would focus on our home waters, on the GI-UK gap, on the Baltic, the Barents Sea, important places for us, but we're not going to bother to extend that, further south into the Atlantic because that would be too much money. And even the US Navy, with a wildly bigger budget than we have, is not going to be able to have a persistent sensor network in every square inch of the ocean. So I think actually what we'll see is a limitation of places where ships can hide. And I think that limitation will be you won't be able to hide on the surface of the ocean because of satellites and aeroplanes and aerial drones and so on. But the subsea domain, I think it will still be possible to hide because the kind of sonar arrays will be focused around particular choke points in important places for
Hmm.
defense. But I still think you're going to be able to hide a submarine in the middle of the Atlantic perfectly easily. Until we have a technology where a satellite can spot a submarine on, close to the bottom of the ocean, that is still very much possible. And particularly if you've got a very nice, new, modern, quiet submarine where you can't hear it going to where it's going and kind of extrapolate where it is based on its movements, I still think it's possible to hide a submarine.
Hmm.
So I don't think we're quite there yet on making the ocean transparent completely. But I think the kind of tactics and thoughts that theorists like Mann and Corbett were having was very much to do with surface fleets because that's what they had at the time.
Hmm.
And I don't think you could hide a surface ship for very long anymore.
I just read about how diesel submarines have to periodically snort, and I just
Yes.
delighted because I love that word, right? So they come up, they snort, and then but you can see it every time it
Mm.
snorts, and then you can map it, and then you can extrapolate from all the snort sightings.
Exactly. And this is why our nuclear deterrent submarines are all nuclear powered, because if you've got a nuclear powered submarine, it doesn't have to snort.
Right.
So then it never has to surface
I just love
unless you
that
want it
word.
to. It's great. It's great.
It's a wonderful word. Yeah, I had to bring it out just so I could use that word. So now, with all these autonomous solutions and drones and this issue of transparency, that clearly information and information management must be significant challenges, or perhaps even growing challenges for modern navies. So, do you have any thoughts on that?
I do. I am concerned that with the focus on gathering information and data, I'm concerned that there isn't a sufficient focus on using that data. So data is only useful if you can get something out of it. So if that's ISR, for example, your ISR data is only useful if it tells you where your enemy is and that you are able to track them using that data. I worry that we are not learning the lessons of past historical examples where militaries have been overwhelmed by the amount of data they've collected and haven't actually used it. And of course, the big one there is Vietnam. So the US military in Vietnam were trying to have a very scientific war, a very data-driven war. They collected tons of data, surveillance data, population data, the RAND Corporation did wonderful surveys of villages about their political leanings, and the Ho Chi Minh Trail was covered in sensors that the US military had put there, and they got all of this data, and they never actually did anything useful with it. They didn't have the computing power to be able to find patterns and to pass the data. They didn't have the manpower to be able to do it without computers, and it just meant that there was floods and floods and floods of data and it didn't do any good.
So you're
And
thinking about it at a strategic level, though, rather than
right,
like the level of the data that a commander on a flagship is seeing.
totally, yeah. And especially with these kind of large kind of sensor networks that a lot of navies, especially thinking about to cover big areas of ocean in choke points, those all of those sensors will each be producing data
Mm,
constantly. You have to have the computing power and the time and the system in place to be able to take all of that data, put it together in the right way, spot patterns, do something with those patterns to be able to figure out if it's something that is useful to be passed up the chain, if it's something that is a natural occurrence, if it's something that is an ally going past, not an adversary, all of these questions. If you have so much data that you can't do any of that, then the data is useless. And I mentioned this recently. I was at the Naval War College in Newport and we were talking about naval drones. And I asked this question.
mm.
And the answer I got, I won't say from who, I said, has the US thought about this with kind of experimental drones? And he looked at me and just said, not really, no. And I said, have people learned the lessons of Vietnam? And he just was like, no, I
No.
don't think we have. I was like, great, cool, okay. So that's something that really concerns me, that if there's too much focus on gathering data, that takes away from the concept of using that data, and we need to be able to do both.
I just want to push back a little bit on that. I have
Mm,
done a lot of work that, like when I was at the Rand Corporation, for instance, on Army operations research, which is how I know about like the big data effort in Vietnam and that book by what's his name, Gaddis.
mm.
Yeah, uh, really great book. If I remember where it was, it's somewhere on my shelves. I would pull it out and do like show
I
and
think it's
tell. It.
somewhere on mine as well.
Yeah, yeah, it's somewhere back there. But at any rate, one of the things that I saw in looking at sort of vintage Rand, Vietnam era Rand stuff, but then also contemporary stuff, not that less by Rand, but more about other people, is that in looking at the operations research effort in the wars in Afghanistan and Iraq, is that I was really disturbed by the very idea of using operations research. Actually, like I feel like that it had run amok, and that at least in because of some of the peculiarities of American strategic culture, there was this expectation that operations research would yield great things and would actually be a substitute for, frankly, strategic thinking. And so the Army, the military, I focus on the Army piece, but the military writ large tasked operations research people with basically collecting massive amounts of data and then throwing all this into some like hopper, and then they'd run the algorithm. This is to me how algorithms work. Like this is how like computer processing chips work. They're sort of churning the data, and out would come these insights. And the insights they're asking were like, "Are we winning? How do we know if we're winning?" And basically, like, what's the magic solution for winning? And the idea is that this would be data driven, and they failed. I mean, it's a complete failure. And I look at this and I'm thinking, well, it's because like first of all, the operations researchers should never have agreed to this. And the reason why they agreed to this is I thought that they, as a discipline, this might get me in trouble with somebody, um, they, as a discipline, thought too highly of themselves.
Mm,
In that, like, if you're skilled at this one thing, and operations research is very powerful. I don't want to dismiss it. I'm not dismissing the whole thing, but it's a very powerful discipline. But thus, if you're really into it, they kind of believe that you can use this discipline to solve all things. And thus, there was this almost an act of hubris on the part of the operations research community to say that we can figure this out. Likewise, the uh, the policymakers and deciders and commanders who are tasking the OR operations research people with this job should have known better that that's not going to yield victory. Like this is not how you win. I feel like you're pointing to this idea that well, you're not arguing for operations research, but you're saying that invariably, whether deliberately or not, we are collecting a lot of data. Well, deliberately we are because we're investing in systems too, right? So we're getting the data. But then the question is the data is not being used in any way. So let's say we were to do more with understanding the data. What does that actually get us? Is it just a question of not wasting the opportunity? Like we've got data, we should use it, or is it no, this might actually help us, or what? Like what actually is the problem? So I guess I'm kind of saying like, okay, we didn't do much of any value with the data that we collected in Vietnam, but I'm not sure it really mattered.
Mm-hmm.
Um, because
Yeah, I
our
think
failures in Vietnam were
myriad.
myriad and great, and
Hmm.
it doesn't necessarily matter. So,
Yeah, I think the point I draw the line between where I draw a straight line between Vietnam and now is not what data it is. It's kind of the more the conceptual idea of having data and not using it properly.
mhm,
So the, as you say, the problem in Vietnam was very specific to operational research and it wasn't the same kind of data. So the data we're collecting now is more kind of sensor data, scientific data, numbers, and visual data. And all of this is doesn't have the same problems that you see with operations research because that's like trying to nail jelly to the wall in terms of trying to find out, are we going to win? That's a very human question. And
right, it's a human question.
it's a human question, whereas the questions we're asking now are much more machine questions. So I think we've moved away, thankfully, from that problem in the naval sphere anyway. But then we still have the problem that we still have is this problem of volume. So the for this data to be useful, because the point of collecting this data is to be able to use it for ISR purposes, essentially. So to track, for example, to track a Russian submarine in North Atlantic, just to take an example. So what you want is to be able to have your network of sensors in the Barents Sea and to be able to use those so it will ping up and say, hey, there's a submarine, here it is. This is the direction it's going in. What do you want to do? That's
Hmm.
what you want. And in order for that to be able to happen, you have to be able to use all of the data from all of those sensors for it to be put together in the right way to spot the pattern that is that submarine going past,
Hmm.
and to do that quickly enough for that to be useful. And that speed is what you get from the machine passing of it, from machine learning AI, is spotting those patterns more quickly. And to be able to do that from this wider kind of pool of data. So the usefulness of those systems is not simply the volume of the data, it's that processing and that pattern spotting. And that is something that the US military wasn't able to do in Vietnam with all the data it got from its sensors on the Ho Chi Minh Trail and
Hmm.
elsewhere.
Do you know the story about the urine sensors on the Ho Chi Minh
No,
Trail?
tell me.
So, the U.S. government got this bright idea that one way to sort of gauge the volume, the traffic on the Ho Chi Minh Trail, was they developed these sensors that would somehow detect urine in the air, like certain chemicals that come off with from urine. And so they put these sensors on the Ho Chi Minh Trail, and somehow the Viet Cong figured this out, and so they would look for the sensors, and then they would make a point of when people passed by them, they would urinate on the sensors, which I just love, right? And and I wonder how long it took. I'm sure this is knowable in some book. I just don't remember, but like, how long did it take the U.S. military to realize that um, the adversary was onto them, and that the data they were getting was garbage. But that's also like, how much money did they spend developing this technology? And
Exactly.
it's a very American thing to do. It's like, oh, let's spend money on some technical solution that's going to be really cool, and then we're going to get this data.
I read somewhere that after the war, when the US military retrieved a lot of the sensors, um, Richard Nixon took some of them and put them around his house as a security system.
Okay, presumably not the urine ones.
No, I mean, I don't know what threat he was envisaging. But apparently he thought they were brilliant, and even though they didn't really work, and had them just like put around the landscaping in his garden.
Okay, along with the
Um,
claymores, right?
I assume so. So
That's
yeah,
great.
if any of further Watergate scandal came for him, perhaps that was to
Yes,
stop
yes, yes.
that.
So Emma, I thank you. Emma, thank you very much for taking the time to speak with me. I found this conversation absolutely fascinating, and I certainly hope it's not the last conversation between the two of us. And hopefully next time I'll actually get to meet live. But thank you, and hopefully this is. I'm sure this will be of great interest to people. And I well, I look forward to seeing you again. Maybe I'll have you back
Yeah,
to
that would be
interact.
great.
Yeah,
And yeah, this was super fun. Thank you for inviting
excellent.
me.